To understand the motivation behind our solution, we might take a look at this exemplary industrial production line at first. We have goods running over on this conveyor that are fabricated with several manipulators. The efficiency of the whole production process and the production quality at the end are dependent on how well all these machines and components work together. So there's a lot of interaction between machines and humans and machines that is taking place. And the interaction forces and torques between these components are often unknown, but they're essential for proper handling of the product. So our aim is to integrate sensors for torque measurement, force measurement, and further sensors into existing parts of this production line. In our opinion, this is an essential contribution to the digital transformation process of the production industry. So we are doing this by analyzing this process data with our sensors and analyzing the component states. Furthermore, we translate this sensory data to make it very easy to understand by machines and also the user. There are several challenges in the sensor integration. One is that add-on sensors and strain gauge applications often require an adaptation of the current design. We have a wired measurement chain, which is difficult to include into rotary parts of these processes. And often we do not measure at the interesting spot. Until now, all the sensors that we see have been placed outside. So we ask ourselves, why don't we put them inside the component? That's why our goal is to integrate sensors in existing machine elements, such as tubes, etc., directly at the point of interest. And with this, we want to make new products possible, such as a sensory cardan shaft or even sensory sports equipment. And for that, we have to miniaturize our measurement electronics and put some additional connectivity for wireless sensors to it. And at the end, we also want to simplify the existing measurement change to make sensors and torque sensors accessible to a wide user field at the end. So let's get into detail how our integration or sensor integration works. Our main product consists of a deformation element with strain gauges and sensor electronics with a powerful microcontroller to analyze the sensor data on chip already in the device. Additionally, we have MEMS sensors for acceleration, rotational speed, and further sensor data. And to make it wireless, we use the most recent Bluetooth technology and also a battery or permanent inductive energy. So this standardized package is then integrated into the component. And with this component, we want to measure and monitor the mechanical process. For us, the most important thing is to make the measurement data easy accessible for the users and also control units of the machines. Today, everybody is using smartphone apps. We have developed an app for smartphones and tablets that automatically communicates with our sensors and then displays all the relevant data on screen. And additionally, we have a wireless industrial gateway that transfers the measurement data to a process control unit. So I can ask, have you ever struggled programming an SPS card via a serial port or something else? So this is always difficult to integrate complex sensor technology in an existing line. But with our gateway and with our solution, it's very simple to just configure the analog or digital ports with our app. So everything is inside our app. We can see the measurement data and also configure the gateway. Make it short, the whole measurement chain here is plug and play. So this one sensor element which we developed can be then integrated in different forms and machine parts. The deformation element is completely fixed with the structure and measures every load that the structure experiences. And a wide range of possible application comes with our standardized sensor element. So today we focus mainly on components that are built in the powertrain, so in production facilities or off-highway vehicles. Example products that we already realized with our partners are threaded spindles, screw conveyors, cart shafts, or couplings. So with our help, the supplier of these products now have a smart product on the market and provide a significant added value for their customers. How does the whole measurement chain looks like of our product? Up to 4 sensors are connected to the tablet to view the data or are connected simultaneously to the gateway to transfer the data for a process control unit. Therefore, a machine operator who wants to investigate the current process or the components can know what's going on during the process while just looking on the tablet or the mobile device, while the control unit can adapt the provided power if necessary. We measure torque, force, or bending 500 times per second and acceleration up to 300 G with the sensor unit. The rotational speed is also computed with integrated MEM sensors and signal sensor fusion for rotational speed up to 3000 RPM. The main customer benefit with our sensors for torque and forces differs from each application. So most customers are not really interested in the raw torque signal, but they're in the interpretation of the meaning for their process. So, for example, if you take a look at a sensory cart shaft in a production line, not the raw torque signal is relevant, but we want to know, are there any faults? Do we have an overload? Or is the process not running as I expected it? So our sensor works as an edge device where all the data is already processed in the device. So we implement special events detection features so that this process faults can be first recognized and then displayed as a warning to the machine user or even transferred to the gateway. And if we have this such a fault, the relevant signals, the torque signal curves before and after the event are permanently stored in the internal memory of our sensor device. In safety or critical applications, our gateway is also able to send a fault message to a control unit so that the whole process can stop, so that no further damage occurs. On the following slides, we want to show you that even inside a very limited construction space, we can integrate a sensor and make a sensor out of a mechanical component. In a cooperation with the manufacturer, we built a sensory cart shaft. In this case, the manufacturer provides know-how with the mechanical components and how they are merged together to the final product. And we provide know-how during the production process, how the sensors are integrated securely inside this cart shaft. The main challenges in this production is the welding process and the heat dissipation. Since we have to weld these single parts together where our sensor is located inside, we have to monitor the temperature during this process to make sure that no electronic components are destroyed. So at the beginning of the cooperation with this carbon shaft company, the welding process and the resulting temperature stress of the sensor parts were seen as the most critical point in this production of the new product by the customer. That is why we performed these experiments under real conditions on a welding machine. So for temperature analysis during the welding, we used our built-in sensor in this cardan shaft. So here you see the welding machine, and on the right side you see the temperature over time during the welding process. At the beginning, around 50 seconds, when the machine part was welded, almost nothing happens, and then afterwards we see a heat dispersion in the cardan shaft that decreases again over time. The good thing on this results was that even with this, in this welding process, we stay under the maximum storage temperature of our sensory device. So yeah, that was the first success. So it can that we can build machine parts together with our customer. After the production of the sensory cardan shaft, we can integrate them into a roll forming machine where we want to analyze the process. So this sheet metal forming process is used to manufacture profiles out of coils by various forming stations that you can see here. It's an interlinked machine with a fixed drive ratio. So we have only 1 or 2 motors driving all the cardan shafts, and therefore you do not know how much the torque is in this single cardan shafts in the single stations. Additionally, the sensor integration of regular torque sensors is very difficult. Yeah, there are no cables allowed; they would break, and you also need a retrofitting solution because the machine is already existing, so you cannot change the mechanical components. But what you can do is you can integrate a sensory cardan shaft here and optimize the process. So in this use case of the application of a sensory cardan shaft, we had 2 problems that we addressed. First was the energy efficiency. So it happens that individual forming stages work against each other, and the torques are unknown in this process. And this leads to a very high energy consumption and also into bad quality with the parts. The second problem is that 50% of the time the plant is re-equipped. So if the sheet changes or the product that you want to produce, you have to manually adjust all these different stages with a human worker, and this takes most of the time. And the company who's building these machines found out that with an assistive system based on torque sensors, you can reduce the time by 50%. So at TU Darmstadt, a pilot plant of this intelligent roll forming machine was built, and our sensory cardan shafts were integrated for optimizing the process. So here we have 8 cardan shafts analyzing the process, and they are all measuring or sending wireless data to our gateway, and the gateway is then connected to the SPS. And the main benefit here is that doing the forming process, you can see here, we can monitor and detect the fluctuations that are happening, and then optimize the energy consumption with these different drive torques. So here we see the results of such an experiment. On the left side, we see the different torque moments of the cardan shafts working against each other. So they vary. They are not the same as they should be. And the product falls at the end. So we have a bad quality in the profile. After optimization, when we are using the torque feedback in our app and then adjust the single stages, all platforms work together, and we reached an energy saving potential of up to 60% as a solution. So this was just one example. We have other usage scenarios in mind where our sensor integration gives a huge benefit to the process. One is off-highway powertrain application, and here we can implement overload protections, drive control with these tractors, and also monitor the lifetime assessment. Furthermore, we have process industry applications where we can implement wear detection and predictive maintenance with our sensors. Then we have mounting tools where mostly the forces and torque is unknown, so we can monitor these process forces for assistance. And a further field is sports and rehabilitation, where we can use sensor integration for fitness tracking and gamification. So this is a sophisticated goal and product, and we can only achieve this with strong partners. And one of our most important partners is HBM and their strain gauges, and also services, OEM services for our deformation elements that we are using. So for us, it is important to build up on this long-term experience by HBM, and then produce our sensors on top for future industrial markets. To summarize the presentation, the main challenge is the growing demand on process monitoring and optimization and digitalization of product lines. Our solution that we provide is integrating sensors in machine elements, tubes, etc., directly at the relevant spot, and miniaturizing the measurement electronics with wireless connectivity. We also provide a mobile application to measure and configure our system. Main benefits are that we can retrofit existing product lines with sensor integrated components such as the cardan shaft that we've just seen. With our solution, we provide a robust torque measurement inside mechanical parts and additional data analysis and interpretation inside the device.